Now I'm going to explain John Wheeler's delayed path experiment from a digital point of view, which makes it actually very, very easy what's happening. Let's just remind you, this is the one where the path of a young slit type of experiment is delayed, and it results in a bizarre phenomenon whereby a distant galaxy can send a photon off to the Earth, and depending on how you view the photon, it takes a different path. And it appears completely absurd because if you observe it in one way, the photon went one direction. If you view it another way, it went another direction, like billions of miles different, or a different way round an intervening star. So it appears totally absurd. I mean, how can they explain it something like, well, a signal goes back in time and the photon goes in the other direction, because it's going back in time. Well, that's interesting, but if you look at it from a digital point of view, there's nothing actually travelling from the distant galaxy to Earth, or what is travelling is an algorithm that's actually calculating the travel. So there's nothing actually in our space as we know it, in our physical space, as the so-called physical space. There's nothing actually travelling, but there's an algorithm behind it that's actually calculating where that photon is, and only when it arrives at a location will that algorithm implement itself and give a result, which is basically outputting a value that's received in our telescope. So with that in mind, it's quite easy to change the path of anything, because it never actually went along any path at all. It only has an endpoint. It certainly has to be possible to go down one path, otherwise that it won't give the endpoint. Now the concept of going back in time, well, that may also be a Bohmian type construction in which the output of the photon is actually known at the beginning. I'm not saying it is. It's a possible explanation that since it's a digital system, the photon would actually is only a sequence from start out at the galaxy to finish, and in a digital system that is just a step. So it would be possible to have a weak causality break and the photon to actually know where it's going just after its output from the galaxy. Okay, I know that's probably sounds a bit confused, but there's some ideas there that I need to develop. I'm just talking early in the morning, and what I'll do is include a more complete audio with some equations as well to support this viewpoint. But what I'm basically saying is that there's nothing, well, one thing I'm saying is that there's nothing that's actually travelling from A to B. It's an algorithmic calculation that's actually calculating the position of a photon. And the second thing I'm actually saying could be true is that the actual photon, if it's not interfered with on its journey from the galaxy to the Earth, then it's actually a step. Even though it takes a billion years, it's still a step, and it's left no track of which way it's been either. There's no evidence of which way it went. So it may be possible in a way that it actually knows where it's going to before it starts off. I mean, there's very few quantum changes that take place where actually there's no outcome. I mean, if an electron changes its quantum level in around an atom, it knows the outcome. It starts off on the inner one and rises up to an outer level. It knows where it's going straight away. So in the same way, it could be true that the distant galaxy's photon, even though it's a billion years, it's still actually a step function. Otherwise, how could it even start if it didn't know it's finished? So that's what I'm saying could be true, and it could explain some of the polynomial problems that destroyed Neumann's view of the universe, that it was actually a kind of computer, because of these polynomial problems, and that is a possible answer to that.